Okay, welcome to the first question of the second sheet. This is actually sheet 3, and it's the surface area of a triangular prism. So for the surface area of a triangular prism, we have a whole bunch of faces. So if we look at this one, we have our first face, which is 1, and its matching face in the back, which is 2. We have face 3, which is a rectangle. The other side of that, which is face 4. And then we have the bottom, which is face 5. So we really have 4 faces on this particular prism. So if we wanted to organize that data, we could do it like this. We can go face and the area. Okay. So if we look at face 1, it's a triangle. Okay, and the formula for a triangle is area or is base times height divided by 2. Now this happens to be a fairly easy triangle because it's a isosceles triangle, excuse me, where 2 sides are the same length and the base is a different length, which is 10. So we're just going to do 10 times 6, which is 60, divided by 2, which gives us 30 square centimeters. That's face 1. And since face 2 over here is identical, it also has a surface area of 30 square centimeters. Now, if we're going to go to the bottom, I'm going to put 5 up right now because it's pretty easy. 5 is the bottom of the rectangular prism. It has dimensions of 10 by 20, so its area is 200 square centimeters. Now, here's where it gets tricky. 4 and 5 are going to be a little bit tricky because if we look at this triangle here, there's our triangle. There's our height, which is 6 centimeters, and our base is 10. We don't have this measurement here, which is going to be the width of our rectangle number 3, that tent, if you will, of the prism. So that's a rectangle. We know that the length of that rectangle is 20, but we don't know its width. But if you look closely enough, you'll see that that's a right triangle. And it was an equilateral triangle, but because it's an equilateral triangle, its height actually divides the base, which was 10, into 2 equal parts. So if I take this triangle here, I can actually redraw it over here. This is 6, and this base is going to be 5. And that's a right triangle, okay? So with that, we can use Pythagoras. This is 25 centimeters squared. This is 36 centimeters squared. So the area of this square attached to the hypotenuse of this right triangle is going to be the sum of 36 and 25, which is 61 centimeters squared. Since the square root of 64 is 8, the square root of 61 is going to be approximately equal to, 7.8 centimeters or so. Okay, so now that we know it's 7.8 centimeters, we can put it back on our original drawing. And now we have this rectangle here, which has a width of 7.8 and a length of 20. 7.8 times 10 is 78, so 7.8 times 20 is going to be 156. And since the other side is also 156, we're going to put that down as well. And we just add them all together. We get 60 plus 300. That's 360. 560. 572 square centimeters. I hope you could follow that along. If you don't, come see me for extra help, and I'll explain it again to you a little bit slower.